Right, morning guys. Can you all type your names? I'm just going to start the Teams chat as well. So far I've got 2 of you, 3 of you. Cool. Alright, that should be me joined on Teams. And register. Okay, so we've got Joan, Alex, Fifi, Roddy, Sophie, there, Becca. Anybody else there yet? If so, please comment your names, guys. Right, wait for everybody else. So what the plan is for today is to do past exam questions on the complex numbers topic, and as Callum, hi. So past exam questions on the complex numbers topic to revise the whole thing, and then next week we're going to have a look at revising pure and stats and mechanics. So before we get started, I did get an email yesterday asking me to remind you guys when we start college in September, assuming that we do start college in September, there's going to be tests in both strands of further maths. So with assuming you still have me as well, I'm not sure, it depends if classes move or whatever, but in one class you'll have a pure test on Thursday the 10th of September. And in the other strand you're going to have an applied test on Friday the 11th of September. So those tests are on A-level maths only, so there'll be no complex numbers or matrices, but you need to be revising for those. So if I just write that down, tests in first, lectures back. So that's why we're going to do some revision next week, so that you guys can get me to go over any topics you want. Have you finished pure? Yeah, we already kind of had. This is the start of further maths that we've just done. So matrices and complex numbers was the beginning of the further maths topic. That won't be in the test. The test is just on A-level stuff. Cool. All right. Any other questions on that before we get on with what we're doing today? No. Okay. Okay. I thought I filled this with questions, but maybe I didn't. Right, let's just work our way through these then. So we'll start with. Actually, no, we'll go the other way around. We'll start with this one. So 7-mark question. We'll give you guys 7 minutes to do it. If you could all comment your answers to the Teams chat, that would be brilliant, and also comment if you need any help. Right, so if you guys want to get started, 7 minutes begins now. Right, guys, let's start going through it. Is anybody else there? I'm still missing a few people from the class list. So, still missing Charlie, George, and Leo. Are any of you guys there? No? Alright, ooh, what have I done? That's good. If you guys could start, I've lost it. If you guys could send me your answers, that would be great. I'm going to have to redo this bit. Thank you, Alex. Just got your message. Cool. Alright, so the way to do this one, we're told z equals x plus iy. We're going to find x and y such that z plus 3i times the complex conjugate of z is equal to minus 1 plus 13i. Okay, we got Sophie as well, and Fifi just type in. Cool. So I'm going to say z is x plus iy plus 3i times by the complex conjugate, which is going to be x minus iy, is minus 1 plus 13i. So this is the equation that I need to try and solve. Right, so I'll check those answers in a second. So if we expand that, x plus iy plus 3xi, then we got 3i times minus I is going to be 3i squared, which is minus 3, times minus 1 is 3y, so plus 3y, equals minus 1 plus 13i. Right, so let's get all the real bits and all the imaginary bits together. So we get x plus 3y, and we get plus iy plus 3xi equals 1 plus 13i. So I know that all the real bits must be equal, and all the imaginary bits must be equal. So x plus 3y equals 1, and also y plus 3x is equal to 13. So we're going to try and solve these two simultaneously. There's a number of ways we can do that. I'm going to times the top equation by 3 and subtract them. So times by 3, so 3x plus 9y equals 3. And here we've got y plus 3x is 13. So I go back up to the top here. Subtracting those, we're going to get 9y take y, which is going to be 8y, equals 3 take 13, which is minus 10. So I get y equals minus 10 over 8. Okay. The minus 10 over 8 plus 3x is 13. I'm going to check your answers. I'm going to see if that's right. That does feel a little bit wrong. You guys have got some much nicer answers there. What have I done wrong then? Alright, it was minus 1. I copied it wrong. Okay, right, that makes sense. Right, forget that, guys. I did make a mistake. Yeah, thanks, Fifi. You spotted that as well. So minus there. That's a minus. So when I add them together, so that's going to be minus 3 on the top there. So take those, and I'm going to get 8y is minus 16. So y is minus 2. put that back in. So x is going to be x equals 5. Yeah, cool. Right, so Fifi, good job there. You got your answer right. Excellent. Callum. Yep, excellent. Good job. Sophie. Yeah, brilliant. And Alex. Brilliant. Cool. Well done, guys. Anybody else there? Thanks, Roddy, as well. Cool. Right, let's move on. Alright, this is a big question by the looks of it. So 10 marks, 10 minutes to do this one, guys. Nice summary of everything in this one. So your time starts now. Cool. Right, guys. Let's go through this. If you could send me your answers, even if you haven't finished, that'd be great. So we want to try and find Z2. We know Z2 is 12 minus 5i divided by Z1. So I'll do that down the bottom here. So 12 take 5i over 3 plus 2i. Remember, the way we do that is we times by the complex conjugate. And if we times those out, we're going to get 36 minus 24i minus 15i minus 10, all divided by 13, which simplifies to 2 minus 3i. So that should be our Z2. To take 3i. Cool. Anybody sent me this? Yeah, no, not yet. Did you guys need more time, or do you want me to keep going through it? Comment if you do want a bit more time, and I can give you a couple more minutes if you need. Oh wait, there we go. Cool, back is okay, cool. We'll keep going then. Show on an Argand diagram the points representing Z1, which is point P, and point Q, which is the point representing point 2. So point 1 is 3, 2. So that's point P. And the point Q, 2 minus 3. Alright. Given O as the origin, show the angle P Q. So we're trying to find this angle here. So really we need to find the length of all the sides and then use the cosine rule. I think it's probably the best way about it. Although we got 3, 2, 2 minus 3. Okay, let me just check. There might be a quicker way of doing this. You could use cosine rule, but let's just work out the gradient quickly. So 3, 2, yeah, this is going to be it. 3, 2 will have the gradient 2/3. Q will have the gradient minus 3 over 2. So they are actually perpendicular. So we know that that's a right angle triangle. Therefore, let's just check that again. POQ. Wait, no. Yeah, it's a right angle, so therefore the angle, right angle. So yeah, maybe so. If you've worked that out, let's say the gradient of for OP, and then this is for POQ. Therefore, P and Q right angles slash perpendicular. Therefore, theta is pi by 2. Right, let's just see if you guys got that. Wonder how you guys did it. So Sophie, you did. Okay, you did tan of each little bit. So Sophie did that angle plus that angle. That's a pretty good way of doing it. I like that because obviously you might not see that it's right angle. And Becca did argument of each. Yeah, okay, cool. Added them together. Yeah, those are good methods. Mine's a bit faster, but mine only works in this specific case. Just because I spotted we got 3, 2, and 2 minus 3. Right, what's next? The circle. Oh, I shouldn't have rubbed out that diagram really, but I have. So. Okay, the circle passing through the points O, P, and Q has a center at C. So we had O, P, Q. So a circle passing through this one, something like that, has a center at C. Find the complex number represented by C. Okay. Interesting. Yeah, this one. I'm trying to think. 2 marks. There must be an easy-ish way of doing this one. I'm just going to redraw that sketch. Okay, that's it. Alright, because we know, yeah, sorry, I just need to draw my sketch again. Because we know that they meet at a right angle, that comes from the circle theorem, that 2 chords meeting at a right angle must be chords made from the diameter. So it's about angles, we call it angles in a semicircle. So P and Q must be 2 points on the diameter of the circle for them to meet at a right angle. Remember the angle any 2 chords from these points makes would always be a right angle. That's the circle theorem there. So we can just find the average of points P and Q. No, I've rubbed mine out, I think, haven't I? No, that's all that cool. So we got 3 plus 2 over 2, and we've got 2 plus minus 3 over 2i. So we're going to get 5 over 2 and plus minus 1 over 2i. Cool. Right, see how you guys did with that one. Where's the teams? Back. Yeah, nice, cool, good, like it. Sophie. Yeah, good. Roddy. Yeah, good, nice. Oh, YouTube chat. Where's that? I lost that. Windows. Alright, What's Sophie saying? Yeah, oh, sorry, Sophie. You did say that. I did that. Sorry. Yeah, it took me a little while, but it's because my sketch was rubbish. Okay, where are we at? Find the exact radius of the circle. Cool. The radius of the circle is going to be, well, we know the point. We know the center. We know P. We know Q. We could take any pair of these and work it out there. We could also find PQ and half it. That shouldn't be too bad. It's up to you guys what method you do. We'll look at your methods in a minute. Straight off the bat, I reckon I'm just going to use length of the line equation, I think is what I'm feeling. So, this in green, what we got? Z, what was we doing? P. P was Z1, okay. So we got 3, 2. And we've got 5 over 2 minus a half. I've got chat open now so I can see what you guys say. So yeah, radius of this one, 3 minus 5 over 2 squared plus 5 over 2, 5 over 2 plus, no, what am I doing? 2 plus a half squared, all square rooted. Get up, trusty calculator. That's a quarter. $25 over 4. Square root that. You get root 26 over 2 for my answer. Goes to distance from the origin. Oh yeah, because the origin's on the circle as well. This is what happens when you don't have a sketch in front of you. You forget key details like this. Yeah, that'll work just as easily. Alright, quickly looking for your answers. Yeah, nice. Cool. Yeah, Sophie did what I did. Yeah, Becca, good. Cool. Alright, anyone got any questions? I'm aware some of you aren't actually communicating much. Can all of you let me know if you're still there? Alright, let's move on to the next one. So, next one is going to be this one. Shouldn't be too bad, this. It looks pretty easy. So 7 marks, 7 minutes starting from Cool. Right. Yeah, looked good from most of you. So some of you said you did part 0. Yeah. Well, we'll see what happens. Anyway, so find. I'll show you z squared is -5 minus 12i. So doing z times z. So we're going to get 4 minus 12i, and then minus positive, so we need to take away 9 there. Cool, so we get minus 12, and 4 take 9 is minus 5, so that leads us to that. Cool. Right, find the modulus of z squared. So that's going to be minus 5 squared plus minus 12 squared, square rooted. So it'll be 144 plus 25, 169, so that's 13. Find the argument of z squared. So z squared, let's just draw it. Minus 5 minus 12i goes down there. So we need to find this bit, and then we're going to do the argument from x. So if we do tan to the minus 1, 12 over 5, we get 1.76, and if I do pi take that, you get 1.96. So it's going to be minus 1.9 or minus 1.97 there. Cool. Is that what you guys got? What did you guys do? So if you got it, Becca. No, don't know what you've done there, Becca. Yeah, I'm not sure. You haven't got your workings how you got the 0.39, but have a look at that. Callum. The same thing. Oh, you guys did what, x over y? Yeah, okay, easily done. Easy mistake. Yeah, Roddy, good. Alex, good. Yeah, cool. No worries, guys. Right, show z and z squared on a single argand diagram. Okay, well I've already got z squared there. Let's put z on, so z is 2 minus 3. It's going to be there. Cool. Alright, that was pretty easy, wasn't it? That was a pretty nice question. Alright, next one. So please also give me topics, guys. So at the moment, all I've got to go on next week is integration. So what other topics in pure stats or mechanics would you guys like to go over? This looks pretty easy as well. Let's skip this one. 5 looks too easy. Yeah, this might be slightly more difficult. Let's try this one. Okay, so 8 marks, 8 minutes on the clock, starting now. All right, let's have a look. What are you guys saying? Don't have any I. How meant to get informed experts like why? What does that squared have to do with any of that? Oh yeah, what is that got to do with any? Okay. Okay, I think there's more than. I think something's not printed here. Yeah, you guys might be on something. Um, hmm. Find modulus of Z1. Okay, right. Cool. I know it's wrong. That obviously A and B are the same. If you kind of go this, it's actually asking you to find modulus of Z1 over Z2. Cool. All right. If you guys tried that, sorry about that. I'll restart the time. Yeah, sometimes it just doesn't print. Some of these are password questions, a bit old, and words lost, bits and fractions. Yeah, it should be modulus of Z1 over Z2. That's what it wants you to find.
Maybe this is meant
Right, it's got another. I've noticed another mistake, guys. I'm sorry. Fifi, yeah, the question I've just checked the mark scheme. It doesn't actually want the modulus. It just wants Z1 over Z2. So I'm really sorry about that. Because obviously a modulus will come out as a size rather than a X and Y component. All right, let's go through it. I will find the size as well, but yeah, this question has gone badly. So find in form X plus Y Z1 over Z2. So that's going to be A plus IB over 3 minus I. So we're going to times that by 3 plus I. So we're going to get 3A plus 3IB plus AI minus B over 3 minus I. So that's 3A minus B. Wait, I've done the bottom. Yeah. So that should be over 9 plus 1, which is 10. So yeah, 3A minus B over 10 plus 3B plus A over 10 I. So that's what we should get for that. If I wanted to find the modulus, I could. I mean, it's not what the mark scheme's telling me, because obviously we couldn't find the modulus in terms of MB. But we do 3A minus B over 10 squared plus 3B plus A over 10 squared, all square rooted. Going to need that for a minute, I think. So that would give me what, 9A minus 6AB plus B squared over 100 plus 9B squared plus 6AB plus A squared over 100. So the 6AB and the 6AB are going to cancel. So this would leave me with 10A squared plus 10B squared over 100, which is A squared over 10 plus A squared over 10. So that should be the size of it, in case you are wondering. Sorry about that though, guys. Alright, part B. Given that B is minus 2A, so the modulus of A is this. Okay. So, given that B is minus 2A, okay, so we've got A minus 2AI. We want to try and find the modulus of A, so we're going to get A squared plus minus 2A squared or square rooted, which is the root of A squared, plus 4A squared, which is the square root of 5A squared. We can bring A out, so we get A root 5. Okay, and then find the argument of Z1 over Z2. Well, Z1 over Z2 is this thing we found up here. We know that A is root 5, so therefore I can find B, because B is minus 2A. So A is root 5, B is minus 2 root 5. That was my Z1 over Z2. So if I put those values in, we're going to get 3 root 5 plus 2 root 5 over 10 plus minus 6 root 5 plus root 5 over 10 I. Cool, so let's again go a step further and work those out. So we're going to get 5 root 5 10 minus 5 root 5 10. Cool, those will simplify to give us 5 over 2 and root 5 over 2. So the argument we get root 5 over 2 minus root 5 over 2 is going to be there. So the angle is going to be minus pi by 4 is our answer there. Cool. All right. Anyone got any questions? Again, sorry about how badly that printed. Cool. Let's try another one. I'll double check this one first. Oh wow. Okay. Yeah, this should have worked. Okay, so 9 minutes, do this one, and this should be it for today. So if you guys try this one, 9 minutes starting now. Comment if you need any help. Sorry, Fifi. Yeah, so I do apologise. Yes, 9 minutes, try this one, and we'll go through this just before the end today. Right, let's go through this one, and then that'll be it for today. Can you guys also start commenting what topics you want to do next week? Because at the moment I don't have much to go on. Cool. Cool. So find the modulus of W. So we need to do 10 squared plus 5 squared. Square rooted, which is root 125, which is 5 root 5. Argument of W. So tan to the minus 1, 10 over, nope, 5 over 10, easily done. 5 over 10, do a quick sketch, 10 minus 5, there it is. So we're going to have a negative argument. So tan minus 1 of 5 over 10 gives me 0.46. We're going to get minus 0.46. Cool, we'll use algebra to find z. Okay, W, okay. So 2 plus I times by z plus 3i equals 10 minus 5i w from the first bit. So expand that. Oh, that's not a 2. 2z plus iz plus 6i minus 3 is 10 take 5i. Okay, so we're going to look at the real bits and the imaginary bits together. So 10 must equal 2z minus 3, and iz, or even z plus 6, must equal minus 5. So 2z, no, that can be right, can it? Something's wrong here. Do that again. Okay, so 2z plus iz plus 6i minus 3 is 10 take 5i. So, okay, there we go. So 2z will equal 13, and iz will equal minus 11i. Is that right? So 2z is 13, and iz, take that, 0 minus 11. So z is minus 11. No, what's gone wrong here? Can anyone see what I'm doing? Something's gone wrong. Oh wait, z is a complex number. Okay, right, scratch that. Z isn't a number. Z is a complex number. Okay, let's do that again. So, right, instead, what I'm going to need to do is do z plus 3i equals 10 minus 5i over 2 plus I. So we'll do that division, and then we're going to take away 3i. Cool. All right. So if I clear some space at the top. So z plus 3i equals 10 minus 5i, 2 plus I, times 2 minus I, 2 minus I. So we're going to get 20 minus 10i, minus 10i, minus positive, take 5, over 4 plus 1. So we get 15 minus 20i, 5, so we get 3
minus 4i. Take 3i from each side, so z equals 3 minus 7 minus 7i. Cool. Right, and the last bit, given that this is true, the argument of lambda plus 9i plus w equals that, so I don't need z anymore. If I just go up to the top and get w is 10 minus 5i. So we've got arg lambda plus 9i plus 10 minus 5i equals pi by 4. So arg of lambda plus 10 plus 4i is pi by 4. So the real bit and the imaginary bit must make an angle pi by 4. Yeah? Because it's pi by 4, this bit must equal this bit. So the real bit must equal the imaginary bit. So the real bit is lambda plus 10. The imaginary bit is 4. So lambda plus 10 must equal 4. Therefore lambda is minus 6. That's it. Cool. Has anyone got any questions? Fifi, you were good up to where you got to, so you didn't do D, but the rest of it was all brilliant. Cool. All right, that'll be it for today. Could you guys please send me some topics that we can do next week? I will do some integration, but we don't want to spend the whole day on whole week on integration. So any other bits from stats, mechanics, or pure, let me know by Monday. Oh, I just forgot to do the progress check. All right, we'll do the progress check on Monday because I completely forgot again. Yeah, and I'll see you guys next week. Have a nice weekend. Last week next week, week of revision, should be a nice easy thing. Maybe some Cartesian stuff. Oh, what do you mean, Cartesian parametrics, really? Yeah, parametric to Cartesian form? Yeah. Or this stuff, do you want to do more complex numbers, going to Cartesians? Let me know specifically what you want to do. But see you guys next week. Progress check will be the one on what we did last week, which was, is it the loci one yet? Let me just have a quick look in the system. Yeah, I'm going to need to go online for this. I will check. It should be up on Moodle, the next topic. Let's look on Moodle. It is not up yet. Have we done 1.3? We did do 1.35. I imagine it'll probably go up tomorrow. 1.36 is the next one to be done. Yeah, wait and see. Wait and see what goes up on Moodle. Yeah, wait to see if the assignment goes up. If it doesn't go up, I will send an email to find out what's going on, but I can't see it on my end either. All right, have a nice weekend, and I'll see you later, guys. Thank you.